We're going to start with day one. Talk about these notes just for real quick. It won't try to keep it somewhat short, somewhat quick. We're going to start out by talking about things called the reciprocal trig identities and Pythagorean identity. The reciprocal trig identities we've already talked about before, so hopefully these are more just kind of review notes for you. Cosecant is the inverse of the sine, so in other words, 1 over the sine of x. Secant of x is 1 over the cosine of x, or the inverse of the cosine. Cotangent of x would be 1 over the tangent of x, or the inverse of the tangent. And to be honest, this one is used, but it's not used as nearly as much as what I would say is this one right here. By remembering the tangent of x is sine x over cosine x, we can then say the cotangent is the reciprocal of that, which would be cosine x over sine x. And I think this one is probably used more than the other one, but they're both important and both good to know. I think you guys could probably do this part by yourself. I'll just remember this is a 3, 4, 5 triangle, and you can figure that out if you'd like. I'll just write out my answers real quick, so you can check your answers with them and make sure you get the correct answers. Cosecant of c, of course, cosecant 1 over the sine, so the sine of c would normally be 3 over 5, so just reciprocate that, 5 over 3. Secant 1 over the cosine, so again would be 4 over 5, so reciprocate, 5 over 4. Tangent of c would normally be 3 over 4, so cotangent would be 4 over 3. Okay? Now, to get to the Pythagorean identity, majority of you, of course, can all probably got this down pretty well. You remember correctly our unit circle here, radius with 1 unit. If we call this side length A, which of course is also our x value, and this side length here B, which would be our B value of this point. So hopefully you all agree that that point there has the point AB. By Pythagorean's theorem, we could say that a squared plus b squared equals 1 squared. That's Pythagorean's theorem. You could also say, if we want to write this with a trig function, we could say that a, so if you look at theta and a and 1, you could say the cosine of theta, which is the adjacent, is a. So a is actually equal to the cosine of theta, and b is the opposite over 1, which we could then say that the sine of theta is b, because sine of theta would be opposite over 1, so b over 1 is b. We then, by using basic substitution, could say that the cosine of theta squared plus the sine of theta squared would equal 1 squared, or just 1. Now, this is the Pythagorean identity. Just to let you know, this is one way to write cosine of theta squared plus sine theta squared. In most math textbooks and in most cases, you'll actually see it written as either cosine squared theta plus sine squared theta equals 1, or because addition is commutative, a lot of times they'll write it as sine squared theta plus cosine squared theta equals 1. I'm not sure exactly why this is the preferred method, but normally that is how you'll see it. Either one will work. One other way that you could actually write cosine squared and sine squared is you could actually write the cosine of theta times the cosine of theta plus the sine of theta times the sine of theta equals 1. So any of these three ways is correct, and again, because of the commutative property of addition, this is correct as well. So that is your Pythagorean identity. Now, from that Pythagorean identity, we can definitely confirm the Pythagorean identity a couple times. I'll just do one of these real quick. So if I said that we had sine squared of pi over 3 plus the cosine squared of pi over 3, and that's equal 1, then I could rewrite this as the sine of pi over 3 quantity squared plus the cosine of pi over 3 quantity squared equals 1. Remember from our unit circle, pi over 3 right up here, The cosine is the x value, which happens to be a half. Sine is the y value, which would be square root of 3 over 2. So this is square root of 3 over 2 squared plus 1/2 squared. Now the square root of 3 over 2 squared, that's the square root of 3 over 2 times square root of 3 over 2, which would be the square root of 9 over 4, which is just 3 over 4. So it follows that I have 3 over 4 plus 1/2 squared, which would be 1/2 times 1/2, which is 1/4. And 3/4 plus 1/4 equals 4 over 4, which equals 1. And therefore, we could say, oh yeah, the Pythagorean identity works. You can do it with whatever angles you want, but there you go. Now, sometimes it's very beneficial to take that equation, sine squared theta plus cosine squared theta, and solve for sine squared theta, which would mean you would just subtract cosine squared theta over. And we get sine squared theta equals 1 minus the cosine squared theta. And cosine squared theta would equal 1 minus sine squared theta by the same vein. So these are kind of important for us to note, just because they'll help us out as we go to solve some of our puzzles. You can also write it like this, and you might say, how did they get there? And let me show you really quickly how we get to this one right here, okay? So if I start out with sine squared theta plus cosine squared theta equals 1, and I know that to be true. If I want cotangent squared theta, or if I want 1 for that matter, this sine squared right here, I need to divide everything by sine squared theta. And by so doing, sine squared over sine squared is 1, plus cosine squared theta over sine squared theta, well, that's just cotangent squared theta. And 1 over sine squared theta, that is the cosecant squared of theta. So that is how we get to 1 plus cotangent squared theta equals cosecant squared theta. And you'll prove this one in your homework. So you can refer back to this and kind of think of the same idea, but you'll be there. Now, sometimes from each of these identities up here, it's beneficial to write tangent squared theta, which then would be secant squared theta minus 1. And cotangent squared theta, which would be cosecant squared theta minus 1. Sometimes, not always, but sometimes it's kind of interesting to note that right here you have a difference of squares. A difference of squares, which means you could technically also write this as secant of theta plus 1 and secant of theta minus 1. And again, same thing here, a difference of squares would give us cosecant of theta plus 1 and cosecant of theta minus 1. Okay, there's your introduction to Pythagorean identity. Hope that helps out, guys. You're doing wonderful. Keep it up. And we'll see you later.